ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Welcome to the Department of Collegiate and Technical Education. Today in this session we are going to discuss about the characteristics, application of the operational amplifiers and the pin diagram of the very famous operational amplifier MUA741. So ಈ ಇಷ್ಟು ಕಂಟೆಂಟ್ಸ್ ಬಗ್ಗೆ ಇವತ್ತಿನ ಸೆಷನ್ ನಲ್ಲಿ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. So characteristics of operational amplifiers, applications of op-amp, pin diagram of op-amp, that is 741 IC ಬಗ್ಗೆ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ವಿ. And also at the end of the session we are going to discuss about few multi-choice questions as well. So last session ನಲ್ಲಿ ನಾವು operational amplifiers ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿದ್ವಿ. So just to have a recap on the previous session, so let me revise. Op-amps, they are usually referred to as linear devices. So op-amps are the linear devices that can give ideal DC amplification. So they are basically used as voltage amplifying devices, and they are used with certain external feedback components like resistors and capacitors. It is a three-terminal device having two input terminals. One is the inverting input, other is the non-inverting input, and one output. It also requires two DC supply voltages, positive supply as well as negative supply voltages. Op-amp characteristics, they are very, very important because they decide their performance, and best IC can be अथवा best op-amp can be selected for any application. So a knowledge of the op-amp characteristics, ideal as well as actual parameters, it is very, very important to know. So let me start with the characteristics of op-amp. The very first one is the open loop voltage gain. So voltage gain andre enu anta nimage gotte ide. Gain is nothing but output by input. ಓಪನ್ ಲೂಪ್ ವೋಲ್ಟೇಜ್ ಗೇನ್ ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಯಾವಾಗ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ಸ್ಗೆ ಯಾವುದೇ ಫೀಡ್ಬ್ಯಾಕ್ ಅನ್ನ ಕೊಟ್ಟಿಲ್ಲ ಅಂತಂದ್ರೆ ದೆನ್ ಇಟ್ ಈಸ್ ಆಪರೇಟೆಡ್ ಇನ್ ಓಪನ್ ಲೂಪ್ ಸ್ಟೇಜ್. ಸೊ ಓಪನ್ ಲೂಪ್ ನಲ್ಲಿ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಗೇನ್ ಇದೆ ಐಡಿಯಲ್ ಆಪ್-ಆಂಪ್ಗೆ? ಇಟ್ ಈಸ್ ಇನ್ಫೈನೈಟ್. ದಿಸ್ ಈಸ್ ದ ಮೇನ್ ಫಂಕ್ಷನ್ ಆಫ್ ಅನ್ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್. So open loop gain, it is nothing but the gain of the op-amp without any feedback. So for such an amplifier, the open loop gain is infinite. So the gain of the operational amplifier is infinite ideally, but real values, they range from around 20,000 to 2 lakh. So the gain of an open loop operational amplifier, it ranges from 20,000 to 2 lakh. So such a huge voltage gain leads to their various applications. Second one is the input impedance. So we have already discussed in the last session. The input stage of an operational amplifier is a two-input differential amplifier. So this two input differential amplifier give rise to a very high input impedance, that is infinite. So ideally operational amplifiers, they have infinite input impedance. But practically speaking, the real op-amps, they have input impedance, some input impedance will exist. So ideally, because of infinite input impedance, there will not be any current flowing in the input circuit, because practically, since some amount of input impedance is present, therefore there will be some leakage current in the order of picoamperes to few milliamps will be flowing in the input circuit of the operational amplifier. But ideally, there will not be any current in the input circuit of the operational amplifier owing to the infinite input impedance. The third point is the output impedance. So we know that output impedance of an operational amplifier is 0. Yes, the ideal operational amplifier would have an output impedance of 0. But some amount of real op-amps will possess some amount of output impedances that will range from 100 to 20 kilo ohm. ಆ ರೇಂಜ್ನಲ್ಲಿ ಔಟ್ಪುಟ್ ಇಂಪಿಡೆನ್ಸ್ ಇರುತ್ತೆ practically speaking, but ideally operational amplifiers will have an output impedance of 0. Now let's move on to the fourth characteristics of operational amplifiers, that is the bandwidth. What do you mean by bandwidth? Bandwidth, it is nothing but the range of frequency of a signal that can be amplified. So the operational amplifiers have infinite bandwidth, that is any frequency range signal can be amplified from DC to high frequency AC signals. So as I said, operational amplifiers have an infinite bandwidth. An ideal operational amplifier, it has infinite frequency response, that is they can amplify any frequency signal from DC to the highest AC frequencies. But in reality, op-amps, their bandwidth are to some extent limited, but ideally speaking they have infinite bandwidth. So let's consider the offset voltage. Offset voltage andre when there is no input at the input of the operational amplifier, athwa if you are applying 0 volts at the inverting and non-inverting inputs, or if you are applying the same input on both the inputs of the operational amplifiers, the output voltage must be 0. Output voltage would be 0 at the output of the operational amplifiers, because we know that the operational amplifiers, they amplify the differential input, the differential voltage applied at the two terminals, input terminals of the operational amplifiers. Otherwise, the output would be 0 if the difference between the inverting and non-inverting inputs is 0. So this is called offset voltage. But ideally, offset voltage of an operational amplifier is 0, but real op-amps would have some amount of output offset voltage. Now let's move on to the sixth characteristics, that is common mode rejection ratio, CMRR, common mode rejection ratio. What is this common mode rejection ratio? So as we have already discussed in the earlier session, operational amplifiers would amplify the differential voltage applied at the two inputs of the operational amplifier, and it would reject any common signal. So common signal enide adanna operational amplifier reject ಮಾಡುತ್ತೆ, only the differential voltage is amplified. So ideal operational amplifier would have a common mode rejection ratio of infinite. So our ideal operational amplifiers would have infinite common mode rejection ratio, andre common signals na infinitely reject ಮಾಡುತ್ತೆ. So the common mode rejection refers to the ability of the operational amplifiers to reject the common mode signal. So therefore, it will reject any signal which is common to both the input terminals, and it would allow only the differential voltage to be amplified. But real op-amps will have finite CMRR, that is common mode rejection ratio, and it will not reject all common mode signals practically. Next, let's discuss about the slew rate. So the ideal operational amplifier have a slew rate of infinite. So what do you mean by slew rate? It is the rate at which the output of the operational would change to the application of the input. So upon the application of the input, how long the output of an operational amplifier would take to change its state. So the slew rate is nothing but the rate of change in the output voltage caused by a step change on the input. Usually it is measured as a voltage change in a given time. Typically, it is represented in terms of voltage per microsecond or voltage per millisecond. So, typical slew rate of operational amplifier is 0.5 volts per microsecond. Andre ಪ್ರತಿ ಮೈಕ್ರೋಸೆಕೆಂಡ್ಗೂ ಒಂದು ಮೈಕ್ರೋಸೆಕೆಂಡ್ಗೂ ಆಪರೇಷನಲ್ ಆಂಪ್ಲಿಫೈಯರ್ would change its output would change its output by 0.5 volts. So this is slew rate. Ideally it is infinite, but practically it is 0.5 volts per microsecond. Now let's consider the pin diagram of the operational amplifier. So here the IC that we have considered is 741, which is very widely used in all sort of electrical and electronic applications. It is an 8-pin IC. IC 741 op-amp, it is an 8-pin IC. The pin configuration of IC 741 is given below. As you can see here, two input terminals. One is the inverting input, other is the non-inverting input. One output terminal and two terminals athwa two pins for the supply voltages. One for positive voltage and the other for the negative voltage, and the remaining two are the null adjustments. We will discuss about the null adjustments later. So this is the pin diagram. As you can see, there are 8 pins in the IC. So there is a notch on the top of the IC. So on to the left side of the notch, the pin number 1 starts. So the numbering of the pin, it starts from the left side of the notch. So pin number 1, offset null. Pin number 2 and 3 are kept aside for the two input terminals. Pin number 4 and pin number 7 for the supply voltages. For the pin number 8, we don't have any connection. It is left open. It is only provided for the sake of equality of numbering of the IC. And pin number 5 is the offset null. Pin number 6 is the output. So again, this is the pin description. Pin number 4 and 7 are the power supply. Pin 7 is the positive voltage supply terminal, and pin 4 is the negative voltage supply terminal. The voltage between these two pins can be anywhere between 5 to 18 volts. So supply voltage, DC supply voltage ಏನು ಕೊಡ್ತಾ ಇದ್ವಿ, it is between 5 volts to 18 volts. ಮತ್ತೆ the signal to be amplified, ನಾವು ಏನು signal apply ಮಾಡ್ತಾ ಇದೀವಿ at the input to be amplified, it always swings between this plus and minus voltage. Pin number 6 is the output. So IC 741, pin number 6 is the output. The voltage at this pin depends on the signals at the input pins and the feedback mechanism used. Pin number 2 and 3 are the inputs. Pin number 2 is the inverting input and pin number 3 is the non-inverting input. Pin number 1 and 5 are the offset null. Because 741 op-amp, they provide very high gain, even a small difference in the voltages at the inverting and non-inverting inputs can influence the output to a very large extent. So in order to nullify this effect, an offset voltage can be applied at pin number 1 and 5. If at all required, an offset voltage can be applied at pin number 1 and 5. And the application of the offset voltage, it is via a potentiometer. Finally, pin number 8. So this is there no connection at this pin. This pin is not connected to any circuit inside the 741 IC. It is just a dummy lead used to fill the void space in the standard 8-pin packages. So this is all about the pin description of the IC 741, which is very commonly and widely used in various electrical and electronics circuitry. Let's discuss about the various applications of operational amplifiers. As we all know, op-amps can be used to amplify both AC as well as DC signals and can be used in both linear and non-linear applications as well. So the following are the very few basic applications of operational amplifiers. As we all know, operational amplifiers, apart from amplifying signal, it can also be used to perform certain mathematical operations like inverting mathematical operation, non-inverting mathematical operation, summing, comparator. So based on that, it can be used in the following applications. To start with, inverting amplifier. It can be used as an inverting amplifier, as non-inverting amplifier. It can be used as a voltage follower. It can be used as a summing amplifier, that is addition of input signals. It can be used to compare two signals, that is as a comparator it can be used. It can be used to filter. So op-amps are used as high pass and low pass filters, that is active filters. It can also be used as a phase shifter. It can be used as a differentiator and integrator. It can also be used as voltage to current and current to voltage converters, and finally they are used as rectifiers as well. So these are the few applications to mention of operational amplifiers. So till now what we have discussed, we started with the characteristics of operational amplifiers, starting from the open loop voltage gain, which is infinite, and the input impedance, which is also infinite, output impedance, which is 0, the bandwidth, it is infinite, and offset voltage, it is 0, common mode rejection ratio, it is infinite, and the slew rate, which is also infinite. These are the 7 basic characteristics of operational amplifiers. And we discussed about the pin diagram of IC 741 operational amplifier, and we also discussed about the applications of operational amplifiers. So in order to summarize the contents of the session, let me pose you a few multi-choice questions. The first question is, find the output voltage of an ideal operational amplifier if V1 and V2 are the two input voltages. So if V1 and V2 are the two input voltages applied at the inverting and non-inverting terminals of the operational amplifiers, what would be the output voltage? So we know that output voltage, it is nothing but the product of the voltage gain and the difference in the input voltages. So option B, that is V out is equal to A, which is the open loop voltage gain, into V1 minus V2, that is the difference of the two input voltages. So option B is the right answer. The second question is, which of the following electrical characteristics is not exhibited by an ideal op-amp? So make a point, not exhibited. Infinite voltage gain. Yes, op-amp, it has infinite voltage gain. Infinite bandwidth. Of course, operational amplifiers, they have infinite bandwidth. It is also true. The option C, infinite output resistance, and option D, infinite slew rate. So as we all know, option A, option B and option D are true electrical characteristics, whereas option C, which says infinite output resistance, is false. So this is the characteristic which is not exhibited by an ideal op-amp. An ideal op-amp, it has zero output resistance. So option C is the right answer. So now let's look into the third question. The common mode rejection ratio is very low, as high as possible, equal to the voltage gain, equal to common mode voltage gain. So the common mode rejection ratio is equal to the common mode voltage gain. Option D is the right answer. Question number 4. Which factor determines the output voltage of an op-amp? So let's look into the options. Option A, positive saturation. Option B, negative saturation. Option C, both positive and negative saturation voltage. Option D, supply voltage. So the output voltage would swing between the two saturation voltages, that is positive and negative DC voltages. So option C is the right answer. So that's all we have for this session today. Thank you very much. Let me end this session now.